Hi, this video is part of Earth Surface Environments Lecture 8, and here we are specifically speaking about the hysteresis effect, which we said would be important in geomorphology. It would be connected to process systems, cascading process systems, how different events in place and time can be connected together. So that's why this is important, because that's the essence and the beauty of geomorphology. We're not just looking at individual rocks or simple definitions, but we're thinking about processes that might be a little bit complicated. And what we see here is this set of charts, which you find in my earlier lecture number 7. So this is in the PPT with black and white. Here I use colors, and just a little explanation what it is about is Q showing discharge. Discharge means the amount of water flowing through the section of a river at a certain point of the channel and at a certain time. So it's basically the amount of water. You can imagine it as the height of the water in case of a flood, for example. And we have SSC, so suspended sediment concentration with red, and that would mean how many tiny clay or silt or such materials, so grain sizes, those particles would be found in the water. We're not speaking about bedload or sand or rocks, but smaller pieces of material floating in the water that make it maybe darker in its color in the case of a flood. So what we see here is 3 cases. The first one, A, would be more of a general or a neutral case. And here we see Q and SSC on the same vertical axis, and T is time, so how the flood event is happening in this case in time, what we see. So as the water discharge is growing, at the same time suspended sediment concentration would be growing as well. How can this happen? Floods would be meaning that the water has a higher velocity or more turbulent it will become. It can capture more sediments from the slope as well if we think about a lot of rainfall, and that means that the sediment concentration could be growing at the same time as the water discharge, and the both of them would be returning to an earlier condition by time. And how we can think about this in case of the relationship of sediment concentration and discharge? Well, we can say that here it would mean that the growing discharge would come together with growing suspended sediment concentration as well. So over here, what we got, both values would be growing, and the decrease can be happening the same way. So as the water discharge would be decreasing, the sediment concentration would decrease as well. Now this is a plain example, so we can make it a little bit more complicated, or in real life other events can happen. And here what we have, B, would mean a situation when we say that, for example, we have a field and we'd have like grass here whatsoever, and there would be a lot of like rain. And what would happen is, first the water would come down, run off, and there would be a flood event, or the discharge would grow. But over here it would take a certain time for all the little particles, and then I can just think here about actually these sediments as well, what you find over there in that drawing. So parts of silt, particles of silt and clay, until these would be running off the surface into the river channel and enter the river itself, so that the suspended sediment concentration would rise. So it might take some time for these materials to loosen up. And that is why in this chart we see that first the discharge would have its peak, and already perhaps it could be decreasing while the sediment concentration is still rising. What it means that we have a growing flood, and the flood already is decreasing in its height. We say, oh, we're over the flood, but actually that's when it becomes more muddy, having more higher sediment concentration. And that is what we can show in like this chart with relationships. So first, the discharge would be growing. Over here, we see that the sediment concentration starts to grow as well, but over there you see that the growth of the discharge first is much faster. And perhaps over here, you'd say, right this point over here would be over there in time when the discharge has its peak. And it starts decreasing, so it's turning on this axis closer to the origin, to the zero, but at the same time the sediment concentration is still growing, so we're still growing up over here, and that means we're still growing over here as well. And it's only after a long time that over here the sediment concentration starts to decrease and return to normal as well. Okay, what is C then? So that will be another case, and this we said could be about like a desert environment. And in this case, again, we can have this piece of land. I just put here a cactus to show that perhaps this would be a desert. Maybe there's a lot of sun. We have rocks on the surface. Perhaps we have a lot of like dust. And what can happen in this case? We have a sudden event of like a rain. So again, a special event, like clouds, no sun anymore. The sudden rain event would mean that we have these tiny particles of sand, clay especially, and silt, and these would be very quickly running off the surface. But once they are gone, perhaps we have more like bedrock here. So these areas would not be able to be washed off by the water, so the runoff will not affect the surface, other than those particles then can be very quickly being washed off. And that is why we say that over here we would have first a quick growth in sediment concentration, and then perhaps the sediment concentration is already decreasing when the flood height and the discharge is still moving upwards. And that's what we see in this chart here, showing relationship between sediment concentration and the discharge. So first we see that the discharge is moving only a very little bit, or perhaps it's not moving yet on this scale or on this axis, but it's the sediment concentration were a very quick and sharp increase, which should be shown. So we go up over this axis, perhaps reach over here. What is this point? This is the maximum value of sediment concentration, somewhere over here. And then we see that the discharge is also increasing. And here we see that the sediment concentration starts to decrease, but the discharge is still increasing, more and more water flowing out. So this point would be when we have the maximum of the discharge, and that would be over here. And then we can say that already sediment concentration has decreased this value over here, which we can show over here on this axis. And then we see that both of the values would decrease, but the sediment concentration would be decreasing a little bit slower from over here, and it's a much faster decrease of the discharge right over here. So that is what we can imagine here as three different cases